Spanish flan is the delicious and culturally significant cake known for its sweet caramel topping and its characteristic gelatinous jiggle. A go-to meal for any celebration, this cake originated in 15th century Rome and was found in a variety of different flavors. After the fall of the Roman Empire, this custard gained popularity in Spain and quickly became an important cultural food. Flan's unique movement leads you to wonder, what makes flan jiggle? In order to answer this, of course, we must first understand flan's composition. Typically, the ingredients used to make flan are 3 large eggs, a cup of caramelized sugar, a can of sweetened condensed milk, a can of evaporated milk, and vanilla extract. In reviewing these ingredients, it is apparent that the only 2 components of flan that have the potential to solidify are milk and eggs. But which one is it? Which one causes flan to have its characteristic jiggle? In order to determine this, we must first understand how both milk and eggs react when they are heated. In its normal liquid state, the proteins within milk are found in a tight jumble with loose bonds. As it is heated, milk separates into whey, its liquid base, and proteins. As they congeal, these proteins separate from the whey that makes up the liquid portion of the milk. This process creates solids referred to as curds. Because these 2 components separate rather than create a single unified solid, we can conclude that milk is not the congelative factor that gives flan its characteristic jiggle. Next, let's look at eggs. The proteins within a raw egg are found in a coil with loose amino bonds. As they are heated, these bonds unravel and eventually they form long chains with strong amino bonds. When heated, eggs do not separate into components as the fat within the eggs actually adopts the structure of the proteins. This means that when eggs are heated, they will form a solid product. From here, we can conclude that eggs are essential to the structure of flan, but just how much do they affect its malleability? In order to test this, I made 4 different flan cakes, each with a different amount of eggs. So our next step is to determine the malleability of each of the flan cakes. We will allow each sample to sit out for 30 minutes prior to the demonstration. We will be determining the flan's malleability through visual and textural cues. Now that we've conducted both the visual and textural tests, we will drop the flans from a height to see how they react on impact. We'll be dropping from a height of 36 inches. Sample number 3, with only 1 egg, was far more malleable than sample number 1, which contained 3. Though the number of eggs may not have affected the flan's characteristic movement, it definitely impacted its structure. This unusual cake demonstrates the importance of chemistry as it shows how our understanding of matter and its physical states affects our ability to express our culture through items like food.